All right, goal 3.3 is on applying the distributive property. We have used the distributive property several times already. We have not used it, however, with exponents. So, because distributive property means that you're multiplying, what are we going to do with the powers? Add them. Okay, so when you're multiplying, you're adding powers. You're still multiplying coefficients like you always did, but you're going to be adding exponents, adding the powers. We know that we're using distributive property when we have that monomial term here, a single term with no addition or subtraction. It could be negative, but these are all single terms. And then inside the parentheses, there are two or more terms. That's when you're using distributive property. Again, we've done it several times already, just not with exponents. So when I distribute 2x to the understood 1 times x to the understood 1 is 2x to the second power. Again, that's like a 1 plus 1 is 2. 2x times positive 3 is positive 6. And then my x just comes over. Final answer, because those are different, I can't put them together, can't do anything else. Understood 1 here. So 1x squared times 5x to the third, positive 5. And then x to the second times x to the third, add those powers, x to the fifth. 1x squared times minus 15x squared. 1 times minus 15 is minus 15. X squared times x squared, add the powers. X to the fourth. And then lastly, 1x squared times positive 2x. 1 times 2 is 2. And then on my powers, add those 2 plus an understood 1 is 3. Those are all different, so you're done. You can't go any further. Lots of stuff on this next one. 4 times 2 is 8. X squared times x squared, 2 plus 2 is 4. And then y times y squared, 1 plus 2 is 3. All together, because there's 3 things in parentheses. So here's multiplying by the first one. Now by the second one. 4 times negative 3 is negative 12. 2 on the x's now, powers. 2 plus 1 is 3. And on my y's, 1 plus 4 is 5. And then my third one. 4 times 2 is 8. There are no variables on this term inside here with the 2, so that x squared y is just going to come over. And that's my final answer, because all those are different from each other. Understood 1, understood negative 1. So 1 times negative 1 is negative. X times x squared, x to the third. One understood times 3 is positive 3. X times x, add those powers, x to the second. X times 1 is 1x, or just x, whatever you like. Doesn't matter. So I finished that parentheses. Go to the second one now. 2 sets of distribution. Positive 3 times positive 4 is positive 12. And my x squared comes down with that 12. And then positive 3 times minus 5, minus 15. Now, because we did two sets of distribution in the one question, there's possibly some like terms. And there are. Those are alike because they're both squared. Just in a second. So positive 3 and positive 12, positive 15. X squared, don't change the power when you're adding. Ready?
So for the first part, you have 12x to the second power. Why wouldn't it be to the third power? Because you can put an exponent by the 3.
But it would be, the 3 is the coefficient. So I'm just taking the coefficient times the coefficient. And then the x squared comes down. So there's no x there. If there was an x, then it would be x to the third. Okay, take a second, a minute, 30 seconds, I don't know. Look those over and see if we have some questions on the distributive property like you've seen before. Josh?
For the last one, why wouldn't you minus 3x squared?
Why is it this a minus?
Yeah.
Because it's going to be a positive times a positive.
Why wouldn't you minus 3x on the 12x squared? Like the 3x squared minus 12.
Positive 12.
Positive.
Because they're both pluses.
Okay.
So you're thinking of solving. If you're going to move things from one side of the equal sign to the other, then you change the sign. But if you're just combining, don't change any signs. Okay, distributive property, we've seen that before, just not with powers. That's the only difference today with that, okay? Now, we're expanding, we're applying the distributive property in everything we're doing today. We are going to talk specifically about multiplying a certain kind of polynomial times a certain kind of polynomial, specifically a binomial, which means two terms, times another binomial, two terms. And when you multiply these kind, you can use an organized way of doing it called FOIL. Now what I have found that some people have heard of this and some people have not. It's an acronym that just means or stands for multiplying in this order, first times the first term, the outer times the outer term, the inner times the inner term, and the last times the last term. You're just using distributive property. The concept of FOIL, however, is hugely important for Super Bowl 4. Okay, it's really not that important today. It's really not, because I could just teach it as distributive property and it wouldn't be a big deal. I don't have to use FOIL to do what I'm doing. But by learning it now, it really helps with the next stuff. Okay? Now keep in mind, I can only use it when there's 2 and 2. So when we're looking at a binomial, let's make sure we understand what first, outer, inner, last means. The first terms represent the first terms in each of the parentheses. So this x with this x. The outer represents the 2 terms on the outside of the question. The inners represent the 2 things on the inner side of the inner part of the question. And the last means the last term and the last term of each of the parentheses. And really, it's just distributive property again, okay? So, first times first. And you don't have to draw the lines and arrows and all those little arc things that I'm doing. If you don't want to, you can, but certainly don't have to. So first times first, x times x, x to the second power, not 2x. We're multiplying here. Outer times outer, x times positive 3. Positive 3x. Inner times inner, positive 7 times positive x, positive 7x. And last times last, positive 7 times positive 3 is positive 21. So all I did was I took x, the first term here, times that one and that one. And then I took positive 7 times that one and that one. I distributed twice, but I just did it organized way. Now, many times, but not always, when you FOIL, you get like terms to put together. The outers and inners are typically the like ones. That's important for goal 4. So 3 plus 7, both positive, is positive 10x. And remember, when you add, you don't do anything with that exponent. Or with that variable, sorry. Or exponent. So final answer. X squared plus 10x plus 21. Hannah.
Why wouldn't it be like 10x squared?
Because we're adding. And when you add, you do nothing with the powers. If we're multiplying, then we get a square. Yes?
Can you do like the box?
I don't know what you're talking about, but if you know what you're doing, then yes. You have to show me later. Okay. Okay, next question is a binomial times a binomial. First times first, 3x times x, 3x to the second. Outer times outer, 3x times positive 1, positive 3x. The inner times the inner, negative 5 times positive x is negative 5x. And last times last, negative 5 times positive 1 is negative 5. And like I said, often, but not always, I'll get one that's not, so you'll see that. These outer inners are alike, so they can be combined together. 3 minus 5 is a negative 2. So final answer, 3x squared minus 2x minus 5.